All right, the topic for today's compare functions we're going to be looking at in our notes, questions 17 and 18. Now, looking at 17, we're looking at these functions. Let me read this question. Suppose that we have Brett and Andre each throw a baseball into the air. The height of Brett's baseball is given by the formula ht is equal to negative 16t squared plus 79t plus 6, where h is in feet and t is in seconds. So interesting. Before I continue reading this, let me pay attention to this formula. What is it exactly saying? So we have a guy, Brett, he threw the ball, and then this formula will give me the height. If I know the time, if I know the time given there, so I want to know what's the height after 2 seconds, what's the height after 3 seconds, what's the height after 1.5 seconds. If I want to know what's the height, but I know the time, I'm going to replace the value of t. You guys see the values of t. I'm going to replace them with the seconds that I know, and then the result will be the height. So this thing will give me the height. Now, what if I do know the height and I want to know the time? Well, in that case, if I know the height, because I can ask you guys, well, what was the time when this ball was 20 feet high? So if you do know the height, you're going to replace this h of t. Notice I call it of t because it's the height depending on the time. So you're going to replace the height there and then solve for t. And then the t will give me the time. Pretty cool thing. I know we've been working on quadratic. So this thing where my highest exponent is 2, that gives us a U shape. It's either open up or open down. My first symbol, the first number is negative, so I know this is an open down shape. So we've been working on that. And a couple of things we work as a vertex. The vertex is basically the highest point in this case. So if I want to know what's the highest this ball is going to go, I can pretty much solve for the vertex. If I want to know when does this ball hit the ground, when does this ball it's at the bottom, well, we talk about zeros. Remember, in this unit we talk about factoring. We can factor it and find the zeros that way. Another way we learned it was the quadratic formula. Remember the negative b plus or minus the square root of b squared minus 4ac all over 2a. That's another way we can solve for the zeros. So if I need to know when does this thing hit the ground, that's something that I can do. So we talk about bread. Cool. I have a lot of information about bread. Now, when I continue reading this, the height of Andres' baseball is given by the graph below. Okay, cool. Kind of looks like the shape of what I'm expecting for bread. So the shape below is pretty much what I'm expecting for bread. It's going to be a difference on the numbers. So I'm going to be comparing these two. So remember, for bread, I have the equation. For Andre, I have the graph. So let's take a look at the first question. Whose ball was hired at zero point 0.5 seconds? Now, I don't want us to just take a guess. I think it was Brett's ball. I think it was Andres' ball. I don't want us to just take a guess. So we're going to figure it out. We're going to figure out the height of each, and then we're going to solve, we're going to be able to tell. So for the formula for Andre, let me use his formula. Remembered h of t, the height of the ball was the formula that we were given was negative 16 t squared plus 79 t plus 6. And then I remember I just said a few seconds ago, if you know the time, in this case, the time is zero point 0.5. If you know the time, replace that number that you know, replace the time for t. So what I mean with that is instead of t, so let me erase this t and let me put the number zero point 0.5 instead of t. And then over here as well. So I have 16 times zero point 0.5 squared plus 79 times zero point 0.5 plus 6. Okay, I'm going to type it on my calculator. Remember on the left side here on our canvas, on the left side, there's a thing that says calculator. That gives you a link where you can just type all of it at once. I type it on my calculator and it gives me my result here. It is 41.5. Okay, so what does this actually mean? when Brett throws the ball after 0.5 seconds, this ball is 41.5 feet tall. So I know the height of Brett's ball. Good. Okay, I'm good on that one. Now for Andre. So let me label this in blue. That is Brett. On your homework, I will come over and ask you guys something like, what is Brett's ball height at 0.5 seconds? So then we just type in 41.5 because then at the end I have feet. So I just want you guys to type in the number. Now for Andre, I'm going to use the graph. So let me use red for Andre. 0.5 seconds. Okay, so let's take a look at the graph. The time, the numbers below, that's the time. The numbers on the side, so my y-axis, that's the height. So let me find out where is 0.5. I see 0 and 2. Okay, I see 0 and 2. Right in between, so right in between 0 and 2, I'm going to call that 1. So that's 1, that's the height of 1 second. I see 0 and 1. So right in between, right in the middle, that's going to be 0.5. Okay, so I found 0.5 seconds. Let me go up here. Let me see, where do I cross my graph? It's right there. I want to know what's the number here on the left. So let me see. I'm looking at the labels. I see there's 40 and 60. I'm going to say the number right in between is going to be 50. Number between 40 and 60, I'm going to call it 50. I see 50 and 60. So this measurement in the middle, I'm going to call that 55. So my measurement here, I know is more than 50, less than 55. In here, I don't know the exact value, so I'm going to have to take a guess. One of you might say, oh, I think it's 51. Some of you might be like, I think it's 53. Guess what? I'm going to call those correct. 51, 53, you're pretty close. My case, I'm actually going to call it 52. So I'm going to say Andres' height, the ball was 52. Now, when I did the work on Excel, on Canvas, I had it accept more than one possible answer. So I said 52, somebody else says 51, and somebody else says 53. Those three answers are going to be considered correct. So like I said, I type in 52 and it says correct. You type in 53, it says correct. I'm going to accept being a little bit off. Now, somebody says 43, looking at here, looking at my graph. I'm expecting between 50 and 55. Somebody says 43. Yeah, that one's not quite going to work. So 43 will be incorrect. We can be off. We don't have to be exact, but not too off. Okay. So coming back to our question here. We know what's the height of the ball when Brett threw it, 41.5 feet. I know the ball of Andres' ball is 52 feet. The question here is whose ball was higher? Well, 52 is more than 41. So I'm going to answer Andre. Andres' ball was higher at 0.5 seconds. Pretty cool. Now, another question that I could ask you guys, I see here it is, whose ball went higher? Okay. So I got to remember for Brett, I have the function. So I'm going to use B for Brett. I remember the function we had was negative. So h of t is negative 16 t squared plus 79t plus 6. So for me to find out the highest point, what's the highest value of the height in here, it will be the vertex. I remember I gave you guys a formula to find the vertex. For the x value, remember I gave you guys a formula negative b over 2a. Okay, I know my a value is negative 16. I know my b value is 79, and I know my c value is 6. So for my x value on the vertex, I'm gonna go negative 79 over negative 32. At the bottom, I went 2 times a, 2 times a negative 16. That's how I got the negative 32. Type it on my calculator. Good thing negative divided by negative is positive. 79 divided by 32 gives me a long decimal. I'm going to round it to two decimal places. So in my case, I'm going to say 2.47. Okay, this is the X value. So it's just telling me the time. I know the time when this ball reaches the highest point, but it's not asking me who reached the highest point faster. It's asking about which ball went higher. So I do need to know what was the height. So I need to know the y value of my vertex. And I know for that formula, the formula h of t, I'm going to use negative 16 times 2.47 squared plus 79 times 2.47 plus 6. Remember, I'm using the initial formula, but instead of t, I'm doing 2.47. I type it on my calculator, and this gives me 103.52. I rounded my answer to two decimal values. So here, I know my vertex. Let me talk about my vertex here. My vertex is 2.47 for the x value, 103.52 for the y value. Now the vertex, the cool thing about the vertex is it's telling me the time. When does it reach the highest point at 2.47 seconds? The y value is telling me the height, 103.52 feet. So the ball is going to go as high as 103.52 feet, and then it's going to come down. Good. I know that about Brett's ball. How about Andre? What's the highest height of Andre? So I'm going to use red here. For Andre, remember we're using the formula, and we were using the graph, I mean. So the highest point will be about here. That's the highest point. I can look at the X value. It's a little less than 2, about 1.9. It's a little less than 2, but that gives me the time. I'm not interested on the time. I'm interested on the height here. Remember how for the previous question, we figure out that each square was 5. Remember we found 50 and 55. So I see here's an 80. So this must be 85. And that thing looks a little more than 85. Hmm, I'm gonna say about 88, 87, 88. Wanna be a little more, like you guys sometimes say, more accurate. I'm gonna say 87.3. And it's fine. So Andres, I'm just gonna leave it at 87. The height was 87. So I know Brett's ball went 103.52 feet up on the air. I know Andres' ball went 87 feet up in the air. Now the question at the end is whose ball went higher? Well, in this case, Brett. 103.52 is higher than 87. Very cool. I can use that. Now here, whose ball was airborne the longest? Airborne basically means up on the air. So from the time Brett threw the ball and it hit the ground, and then from the time Andre threw the ball and it hit the ground, whose ball was up on the air the longest? Well, hitting the ground is basically our zeros. So let me figure out Brett. Remember, we have a formula, uh, h of t. is equal to negative 16 t squared plus 79t plus 6. I know my A value is negative 16, my B value is 79, and my C value is 6. Okay. And I'm going to use my quadratic formula. As a reminder, what's the quadratic formula? Let me put that in here as in green. I'm going to say negative B plus or minus the square root of B squared minus 4AC all over 2A. I'm going to say this gives me my X values, which are my zeros. Basically, when does the ball hit the ground? Okay. So let's figure it out. The hard part was the square root. Remember the discriminant, we talked about that last week. So that's exactly where I'm going to start. So I'm going to do B squared minus 4 times A times C. In this case, I'm going to go 79 squared minus 4 times a negative 16 times a positive 6. The two negative signs make a plus sign. So I type it in my calculators. I'm going to go 79 squared plus 4 times 16 times 6. Just type it in. I'm just going to type it in. We can figure this out. And it gives me 6,625. And then I'm going to get the square root of that. Now this one, I'm going to round it up. It gives me a long, long decimal. I'm going to round this to 81.39. Okay, now I'm going to be able to plug in my whole formula. Negative B. So I'm going to go negative 79 plus or minus 81.39 all over 2 times A, so negative 32. Okay, so for my two zeros, I'm going to do negative 79 minus 81.39 divided by negative 32. My other zero is negative 79 plus 81.39 divided by a negative 32. My answers here are 5.01 and negative 0.07. Okay, those are my two zeros. Now let's actually talk about the meaning of those. My first zero is when read through the ball, 5.01 seconds later, the ball hit the ground. So 5.01 seconds later. Okay? So the ball was up on the air for about 5 seconds. My other number here says that Brett threw the ball and 0.07 seconds before it hit the ground. So it hit the ground before he threw the ball. That's what the negative means. That one doesn't make sense, right? It cannot be on the ground before you throw it. So that one, we're not going to accept it. I'm going to say Brett was up on the air for 5.01 seconds. The negative, I'm not going to accept it. There's no such thing as it hit the ground before I threw it. Okay, now for Andre. Let me change this for Andre. Let me change this to light blue. Andre. Well, for that, I'm going to just look at the graph. Okay, so it seems like each squared is 0.5. So I see here, this is about 4.05. That's one of my zeros, 4.05. And then here it's a negative 0.5. Actually, no, here it was 4.5, positive 4.5 and negative 0.5. Again, the negative. Can the ball be on the ground before I throw it? That negative, I'm not going to count it, but actually let me see the picture. Notice that the ball doesn't start at zero. And it makes sense because in this case, Andre was probably, I don't think he's more than 20 feet tall. So probably he was standing on a mountain. That's possible. He was standing on a ladder. That's possible. He was standing somewhere. So the ball was about 25 feet up on the air when the time started. So he throws it. So the ball's not on the ground. He throws it, reaches the highest point. Boom. Then it hits the ground 4.5 seconds later. This graph makes it a complete U shape, so it gives me a zero on the negative side, but just to complete the graph. But I'm gonna say it was up on the air. For Andre, it was up on the air for 4.5 seconds. So I know Brett's ball was airborne 5.01 seconds. I know Andres' ball was on the air for 4.5 seconds. Now, the question here is whose ball was up on the air the longest? Well, in this case, I'm going to answer Brett. So I want you guys to not just pick a name. Oh, I think it was Andre. I think it was Brett. Not just picking a name, not just guessing. We're going to find whatever is being asked, as in what's the height, what's the airborne, what's the whose ball went higher. We're going to find out the information for each, for Brett and Andre, and then we're going to answer the final question depending on the answers. Let's take a look at another example here. Suppose Brett and Andre each throw a baseball in the air. The height of Brett's baseball is given by the formula. H of t is negative 16t squared plus 25t plus 75. Now, some of you guys might be like, wait a minute, there's a negative 16. That's what I had on the previous formula. Well, we're gonna get used to the negative 16. That's actually the pull of gravity. Gravity pulls down at negative 16 feet per second. That's what the pull of gravity. So that negative 16 will be there plenty of times. And then where h is in feet and t is in seconds. Okay, so we know the formula for Brett. The height of Andres' baseball is given by the graph below. Good, we know that. So let's take a look at the questions here. Whose ball was hired at 2 seconds? Okay, so let me do Brett. And I know the formula. Let me write it up here. H of t is going to be negative 16t squared plus 25t plus 75. And it's asking me for the height at 2 seconds. So that means t is equal to 2. So I'm just going to go negative 16 times 2 squared plus 25 times 2. I was going to write a t there, but no, it's actually 2 because I know t is equal to 2 plus 75. Yeah, type it in, it gives me 61. Okay, so at 2 seconds, the ball that Brett threw was 61 feet tall. How about Andre? Let me do red. At 2 seconds, I see twos right here. I'm using the graph, so I'm just going to go up, up, and I hit the graph right here. And I look for the information on the left. Again, I see the numbers 80 and 100. So the one in between is going to be 90. I see 90 and 100. The number right in between is going to be 95. So here on my y-axis, each squared I count by fives. I'm going to say this is a little more than 95. So I'm going to call this 96. Andre was 96 feet tall. So I know Brett, at 2 seconds, the ball that Brett threw was 61 feet tall. Andres' ball was 96 feet tall. So the one that was higher, 96 is bigger than 61. So I'm going to choose, in this case, Andre. Whose ball went the higher? What went higher? Whose ball went the highest? So whose ball went higher? Vertex. The vertex actually going to tell me that. So let me use Brett's information. The x value of my vertex, I remember the formula negative b over 2 times a. So in this case, negative 25 over negative 32. Remember, my b value is 25. My a value is negative 16. So that's why I have a negative 32 at the bottom. Negative divided by negative is positive, so that's a good thing. 25 divided by 32 is about 0.78. So this thing just tells me this ball reached the highest point at 0.78 seconds. Doesn't tell me the height, it just tells me the time. For the height, I need to find the y value knowing the time. So I'm just going to go negative 16 times 0.78 squared plus 25 times 0.78 plus 75. Okay, I type it on my calculator and it sees 34.7656. So I'm just going to call this 34.77. I'm going to round it to two decimal places. So 34.77. Again, this gives me the vertex, 0.78 and 34.77. What the vertex means is my x value is the time. It reached the highest point at 0.78 seconds. The second value is the height. It reached the highest point was 34.77 feet. Good. Now let's take a look at Andre. For Andre, I use the graph, right? So Andre, what was the highest value? Okay, so come back to the graph. Let me erase this from the previous question. The highest value, oops, I see it right there. It's a little more than 95. Probably 97. I'm gonna call that 97. So whose ball went higher? I know Brett's ball went 34.77 feet high. Andres' ball went 97 feet high. Oh, well, it's Andre then, right? That's the one that went the highest because 97 is more than 34.77. So in this case, I choose Andre. Whose ball was airborne the longest? Okay, let's use Brett. Let me remind myself of the formula. Negative 16 t squared plus 25t plus 75. That's the equation that we have. So that means my A is negative 16, my B is 25, and my C is 75. And I remind myself of the quadratic formula is negative B plus or minus the square root of B squared minus 4 times A times C, all of this divided by 2A. Right, I'm not going to try factoring. Forget that. It's going to be complicated. Okay, so let's see. I'm gonna do first of all, I'm gonna do the discriminant. So b squared minus 4ac. Remember, I'm gonna do b squared minus 4ac. Once I figure that out, I'll do the square root. So in this case, let me go 25 squared minus 4 times a negative 16 times 75. And then my negative signs become a plus sign. So that's pretty cool. So I have 25 squared plus 4 times 16 times 75. And that gives me 5,425. And I gotta get the square root of that. Now the square root of 5,425, I'm gonna round this to be 73.65. Now to use the whole formula, I'm going to use negative b, so let me see, negative 25 plus or minus 73.65 all over 2 times a. We call that negative 32. Okay, so my calculator, let me go, I'm going to type it in here. So I'm going to go negative 25. I'm not showing you exactly how I'm typing it, but I'm typing it. Negative 25 plus 73.65. At the bottom, I have a negative 32. And it gives me my two zeros that I get. One of them is a negative 1.5. My second zero, I'm just going to change the plus for a minus. And it gives me 3.08. I'm not going to accept a negative time because they cannot be on the ground before I throw it. So I'm going to say when it comes to red, the ball was up on the air for about 3 seconds, right? 3.08 seconds. So let me just emphasize this is red. Now for Andre, how long was up on the air? Let me use the graph. So I see here is 4 seconds. It's a little more than four. Let me see how much was it each squared? I see 0 and 2, right? You guys see 0 and 2? The one right in between 0 and 2 is 1. I see a 0 and 1. The value right in between 0 and 1 is 0.5. So each squared is 0.5. So that means this space right here is 4.5. So it's more than 4, less than 4.5. So I'm going to say about 4.3. So Andre was up on the air for 4.3 seconds. So Brett was up on the air for 3.08 seconds. Andre was up on the air for 4.3 seconds. So the ball that was up on the air the longest, I'm just going to say Andre. Real quick on our homework here. On our notes, I asked you guys whose ball went higher. Notice that I solved for the vertex. I came and I found the time, I found the height. I might just even ask you whose ball reached the highest point faster. In that case, I'm asking you just to compare the X values. So I might ask you whose ball went higher, or I may ask you whose ball went faster. Gotta pay attention to that.